Hi guys, thank you for watching my previous videos. So from my record, this is the last video for Emaths. So today we are taking a look at numbers, ratio, rate and proportion. Without further ado, let's take a look at a question. Part A, find the prime factorization of 2184 and 3150. So let's do it. So 2184, we can split it into 8 and 273. And the 8 we can split it further into 2 and 4. While 273 we can split it into 3 and 91. We can split the 4 further to 2 and 2. 91 we can split it into 7 and 13. Therefore, we have the answers for 2184 equals to 2 to the power 3 times 3 times 7 times 13. So now, let's do it for 3150. We can split 3150 into 50 and 63. And 50 we can further split it into 2 and 25. And for 63 we can split it into 7 and 9. 9 we can split it into 3 times 3. 25 we can split it into 5 times 5. Therefore 3150 equals to 2 times 3 to the power of 2 times 5 to the power of 2 times 7. And we have the answers for part A. Now let's take a look at part B. Find the HCF of these two numbers. HCF denotes highest common factor. And now let's take a look at what is LCM. LCM is lowest common multiple. So later on, when we find the HCF or the LCM, I will teach you how to find HCF and how to find LCM. So now let's find HCF of these two numbers. Let's take a look at their prime factorization. So the highest common factor of these two numbers is they share at least a 2 and at least a 3 and a 7. Therefore, you just find what it shared between them. Therefore, you get 2 times 3 times 7. That will give you 42. Now let's take a look at the lowest common multiple. And this time round, you have to take a look at what they have. So this time round, not what they share. Just take a look at what they have and take what they have with the highest power. So they have 2. So 2 to the power of 3 is the highest power. And they have 3. The highest power is 2. So 3 to the power of 2. So they also have 5. And the highest power is 2. And they also have 7. And they also have 13. So therefore, just pick what they have and pick what they have with the highest power. Therefore, all these circled in blue, take it and multiply them again. You will get 163,800. Okay, now we are asked to express 2184 over 3150. So once again, you can make use of the prime factorization of these two numbers. That means you make use of the answer from part A and continue to do this question and find a fraction in its simplest form. So therefore, you can cancel similar terms top and bottom. So you can cancel a 2, so you get 2 to the power of 2 left at the top. And you can cancel a 3, so you get 3 at the bottom. So you can cancel 7. That's it. You can't cancel anymore, top and bottom. Therefore, sum it up, top equals to 52. At the bottom, you will get 75. Therefore, 52 over 75 is the simplest form for this fraction. Now let's continue to do part D, part 2. So find it as a decimal and give the answer correct to 3 dp. So take out your calculator, you will get 0.693333. So you have a 3 reoccurring, and therefore to 3 dp you will get 0.693. Let me save it before we continue to the next slide. Now let's take a look at a new question. We are asked to express PQR in standard form. Okay, before we continue, I would like to point out that standard form is usually in this form: a times 10 to the power n, while your a must be between 0 and 10 when it's positive. So 360,000, which is your P. I'm sorry, let me correct my mistakes here. So 360,000 equals to 3.6, because we have to make sure that a is between 0 and 10, and times 10 to the power 5. Now let's do it for Q. So Q we have minus 216 times 10 to the power 2. So now let's expand it first. So after expanding it, you will get minus 216,000. And from these, your a must be in between minus 10 to 0. Therefore, you get minus 2.16 times 10 to the power of 4. And now let's do for R. R is minus 0.008 times 10 to the power 7. Therefore, you will get minus 8 times 10 to the power 4. Okay, now we can arrange PQR in ascending order. And by the way, ascending order means from the lowest to the highest. Therefore, R is smaller than Q, Q is smaller than P. Now, let's take a look at C. So, we are asked to find QR and express the answers in standard form. So, we just take what we have, or what we get from part A, and we just multiply them together. Therefore, we multiply minus 2.16 times minus 8 first. So we get 17.28, and we take 10 to the power 4 times 10 to the power 4, we get 10 to the power 8, and therefore we get 1.728 times 10 to the power 9 at the end. So we try to multiply similar terms first. And now let's come to part 2, Q over P. So let's write down what is Q in standard form, and let's write down what is P in standard form. So once again, take minus 2.16 over 3.6 first. Then take 10 to the power 4 over 10 to the power 5. So what you get? You will get minus 0.6 times 10 to the power minus 1. And therefore you get minus 6 times 10 to the power minus 2. And I have made a mistake here. I have ignored the minus sign, so please add it in. So part 3, we are asked to find the square root of P, and you can see that the square root of 36 and 4 zeros equals to 600, and 600 is 6 times 10 to the power 2 in standard form. And now we have come to the new slide, and this slide is about indices. So let's copy down the question before we continue to solve it. Okay, 3 to the power minus 2, we can bring it down because minus 2 is also 2 in the denominator. So anything to the power of 0 is 1. So 11 to the power of 0 is 1. So 8 to the power of 1/3 is cube root 8. So therefore you get 1 over 18 minus half. And by punching the calculator, you get negative 4 over 9 at the end. Now we are asked to simplify part B. So a times a, b times b. And a, we get a to the power of 5, b to the power of minus 3 at the end. In part C, we are asked to simplify this term. And you should see that 1/3 this power is applied to the three terms, 27, p to the power of 6, and q to the power of 4, and similar for the denominator. So with that, we get 27 to the power of 1/3. So p to the power of 6 times 1/3, q to the power of 4 times 1/3, and the denominator, we do it in a similar manner. So in the end, we get 3 p to the power of 2, q to the power of 4 over 3, while the denominator is equal to 5 times p to the power of negative 2, q to the power of half. So we simplify it further. 3 over 5, and we get p to the power of 4, because p to the power of 2 minus 2, and q, we get q to the power of 5 over 6. Therefore our answer is 3 over 5, p to the power of 4, q to the power of 5 over 6. So I hope this question is easy for everybody. It shouldn't be very hard for everybody. Now we have this question. It says Benny typed 1500 words in 30 minutes. Nurul typed 1300 words in 20 minutes. Part A, asked to find Benny's and Nurul's average typing rates. Therefore, B equals to 1500 over 30 words per minute, and B denotes Benny. Therefore, simplify this 1500 over 30, we get 50 words per minute. Okay, let N be Nurul's typing rates. Therefore, we get 1300 over 20 words per minute, and let's simplify this fraction, and we get 65 words per minute. So we have the answers for part A. Part B, we are asked to find the ratio of the average typing rate of Benny to that of Nurul. So 50 words per minute to 65 words per minute. Therefore, you can simplify this ratio. And by the way, ratio can be represented in these two ways. Circle. So in the end, you get 10 over 13. Now, part C. If the number of words typed by Benny is direct proportional to his typing time, so find the number of words he could type in 1 hour 50 minutes. So if Benny's rate is 50 words per minute, so 1 hour 50 minutes is 75 minutes. Therefore, take 50 times 75 minutes. So therefore, you can also take 1500 over 30 times 75 minutes, and you will get 375,000 words. I'm sorry, it's 3,750 words. So we have completed this question. Let me save it before we continue to the last question. Okay, we have a question. A map is drawn to a scale of 1 to 2500. And by the way, the scale here is in cm. So 1 cm on the map is 2500 cm in reality. So now we have 9 cm on the map. We are asked to find what is the actual length in reality. So question mark equals to 9 times 2500. So we get 22,500 cm. And we get 225 meters. Now we are asked to find the cm square on the map, while the surface area of the path is 450 meters square. Therefore, the length ratio is 1 to 2500, and the area ratio is, before that, we can simplify it further. So 1 cm is actually to 25 meters. That is our length ratio. So with this length ratio, our area ratio is 1 cm squared to 25 square meter square. So now we are asked to find the cm square represented on the map with a 450 meter square. Therefore, this time round, our question mark is equal to 450 divided by 25 to the power of 2. Therefore, is 450 divided by 625 equals to 0.72 cm square. Part C. So a lump of tar is used to pave the path, and this whole path is paved. The thickness of the tar is 10 cm. So the thickness of the tar is 10 cm with the surface area of a path 450 meter square. So if the same lump of tar is used to pave only 300 meters square. So if we are only to pave 300 meters square, so our thickness should increase. Because the same volume, you will get more if your area is less. So let T be the thickness of the tar when 300 meters of path is paved. Okay, this question C is linked to part B as well. So with a surface area of path 450 meters square and the thickness 10 cm, so we can find the volume. So this fixed volume, we take it over 300, that will give us our T. Therefore, you can see 300T equals to 450 times 10, and our T is equal to 15. And this 15 is in cm. So I hope you know how to solve this question. And that's the end. Hope you enjoy it. See you again. Bye.